now let's look at spatial velocities. Okay, so we just talked about angular velocities for now. Now let's take both position and orientation information and combine it. Okay, all right, so here's the situation. Here's the fixed frame, S. Here's some moving frame, body frame B. Okay, it's moving in some fashion. Okay, all right, and we have the transformation TSB. Okay, let's get rid of the S and B for now. So just call it RP01. Okay. Okay, so R is the orientation, P is the position of this B frame origin. Okay, so let's repeat what we did, but this time taking into account both orientation and position. Okay, so think back. What did we do? We said, well, first thing we did was we calculated R dot R transpose, right? And something came out, meant something. Okay, and then we calculated R transpose R dot. Also got something else, angular velocity. So let's repeat that, okay? So let's call this T, keep the notation simple. All right, so let's do T inverse T dot. Let's see what we get. Why not? Okay, so T inverse R transpose minus R transpose P, 0, 1, that's T inverse, times T dot, R dot, P dot, 0, 0. Okay, I'll get 0, not 1. Okay, this is R transpose R dot, R transpose P dot, 0, 0. Okay, what's that? Let's go over there. Okay, that equals R transpose R dot. Flip back 2 pages, check your notes. What was it? Omega B. Okay. R transpose P dot. Well, what's P dot? P dot is the velocity of this. That's P dot. Okay, because this is P. That's P. Okay. P dot's the linear velocity. What's R transpose R? Omega B. So omega B is the angular velocity of this frame. Angular velocity. Okay, let's say that's angular velocity. Let me do that. Okay, let me not call this. Let me not call this P dot. Let me just call it V for now. Okay. So this frame is moving. Okay. The origin has a linear velocity, V, and if the frame is changing orientation, okay, then the frame has an angular velocity, omega. Okay. So anytime you have a moving frame in space, it has an angular velocity and a linear velocity. Okay. All right. So we have omega B. Let's call this V sub B. 0, 0. Okay, so omega B is R transpose R dot, which is what? The angular velocity omega in what frame? In the B frame. Coordinates. Okay. What's P dot? P dot is what? This vector V expressed in S frame coordinates. So R transpose P dot is this linear velocity V. Okay? So V sub B is this linear velocity V, also expressed in B frame coordinates. Okay. All right, so this is kind of nice, right? We calculated T inverse T dot, and we got the angular velocity and the linear velocity, both in B frame coordinates. Okay, that's kind of nice. Now, before we go further, just some of you might be caught in this loop here, think, wait a minute. The velocity V expressed in B frame coordinates. Okay, you might say, well, if I'm standing at frame B and I'm looking at my linear velocity, shouldn't it be 0? Okay, no, that's not what this means. Okay, what this means here is it's the linear velocity expressed in this frame. Okay, I'll take a snapshot and write down this vector using this frame coordinates. That's all it means. It doesn't mean you're standing at B looking at yourself, okay, and measuring your velocity. Okay, that's not what it means. Okay, all right, so this is good. All right, so what's the next thing we should do? What do you think? Well, how about this then? Okay, we did T inverse T dot, so now it's time to do T dot T inverse. Okay, all right. What do you think we'll get? Well, it would be nice if we get omega in S frame coordinates and V in S frame coordinates, right? Let's see if we get that. So T dot T inverse, this time switch the order. R dot P dot 0, 0 times T inverse, R transpose minus R transpose P 0, 1. Okay, so this equals R dot R transpose, and here we have P dot. Let's see, what do we get here? Minus R dot R transpose P 0, 0. Okay, so let's call this, well, here's omega S, which I recognize from before. And let's just call this V sub S. Okay, so if there's symmetry in the universe, right, then I would expect this to be the angular velocity in the space frame, this to be the linear velocity in the space frame. Okay, so let's see if that's true. Okay, so that's true. Omega S is the angular velocity in the space frame. What's that? R dot R transpose is omega S. Okay, so it's minus omega S P, okay, which is a cross product minus omega S cross P. And you say, huh? What's this? You say, you want it to be what? Linear velocity in the space frame. What is the linear velocity in the space frame? What is V okay, expressed in space frame. Okay, anybody? What is it? What should it be? Take a wild guess. So look at your formula. Okay, look at your picture. Okay, and if somebody asked you this question, what would you say? Okay, it's P dot. Okay, so well, we're screwed here. Okay, it's not P dot. It's we have this mess back here. Okay, all right. So this destroys everything. All right, this ruins my day. It's terrible. All right. Okay. So let's figure out what this means then. Okay. Okay. So there is no sort of a symmetry in the universe. You know, we're messed up. Okay. At least we should try to understand what this is. Okay. So let me write it this way. Equals P dot plus omega s cross minus P. Okay, and just indulge me. Why did I write it that way? Okay, so let's draw a picture here. So here's my fixed frame. Okay, here's my moving frame B. Okay, all right. Now those of you who've taken, who've studied velocities in dynamics, okay, you say, oh wait, this looks familiar, right? You've seen things like this before, right? Let me draw this picture. Maybe this will help. So this vector going this way is P, so it's minus P. Minus P is the other way. That's minus P. Okay. Now what's omega? Omega s is the angular velocity of this body. So this B frame is attached to some body. Okay. Let me draw a body. It's going to be a huge body. Okay. Here's the moving body. Okay, it's the moving body. And it's really large. Okay. Infinite. Okay. So this body is moving with an angular velocity. Okay. All right. Now, so here's the body. Now, if you think about that, then you say, aha. Here's the answer. Here's the answer. What is this? This is the following. So if this body is moving, okay, then imagine this point, okay, origin of S, okay. This point is now a point on this moving body. Okay? So if the body moves, this yellow point moves. Okay? The body moves this way, so let's say it moves that way. Okay? So this is the velocity of this yellow point. Okay? So regard as point on moving body. Okay, so as this body moves, okay, this point is going to move. Okay, and that's what V sub S is. All right, so this is gonna you're gonna have to spend a few minutes to think about it. Okay, really convince yourself. Okay, so omega s is angular velocity omega in S frame. And we know that omega b is the angular velocity in the B frame. Okay. V sub s is what? It's the velocity of S frame origin. Okay. Now, don't make this mistake. What's the mistake? Here's a mistake. S frame is fixed. S frame doesn't move. Origin doesn't move. Therefore, the velocity is 0. Okay, that's not what I mean here. Okay, so the S frame origin is now, think of that as a point on this really large body, moving body. Okay, as this moving body moves, this frame also moves. Okay, so V sub s is the velocity of the S frame origin, okay, expressed in S frame coordinates. Okay, kind of weird, right? But now, then what's V sub b? Well, if I write V sub b as the velocity of the B frame origin, okay, in B frame coordinates. Okay, now you look at it and say, maybe there is some kind of symmetry here between V sub s and V sub b. Okay. So let's go over this again. So V sub b is the velocity of the B frame origin, the moving frame, expressed in the B frame. Okay, so here we go. This big body is moving. This frame is also moving. Okay, origin is also moving, has a velocity. Okay, so V sub b is the velocity of this B frame origin expressed in B frame coordinates. Okay. All right, what's V sub s? Okay, so this body is again moving. S frame origin, this yellow point, okay, this point belongs to the moving body. As the body moves, okay, this point also moves. Okay, it's the velocity of this point expressed in S frame coordinates. Okay, so there is a kind of a, okay, so a nice symmetry here. Okay, it's kind of, it's different from, right, what we're used to thinking about, like linear velocities, okay? But I want you to get used to this idea, okay? Because, okay, so whereas you know, so far you've been taught to think of angular velocities and linear velocities sort of separately, right? Linear velocity is three-dimensional velocity vector, angular velocity, three-dimensional velocity vector. They live in different worlds, okay? Okay, so let's get over that. Okay, so let's think six-dimensionally now. Okay, so I'm going to stack these. I'm going to call this large V sub b a six-dimensional vector in which omega b and vb are stacked on top of each other. Okay, and V sub s is omega s and V sub s stacked on top of each other. Okay. So now when you see a moving body with a frame attached to it, I ask you, what's its velocity? All right. When I ask you what's its velocity, I'm going to mean what is its six-dimensional velocity? Okay. Don't say, well, its angular velocity is this and its linear velocity is that. Okay, that's the old-fashioned way. Okay, the cool way is to now say, oh, its 6-dimensional spatial velocity is this. All right? So it's a little different from what you've been, how you've been trained so far. Okay, but this is going to, all right, this 6-dimensional way of thinking, okay, is going to really pay off later. All right. One final thing, I want you to just, one final piece of notation. Okay. All right. So when I write VB inside square brackets, okay, I'm going to mean this. Okay, it's the 4x4 matrix version. Okay, and same thing with V sub S. Okay, it's the 4x4 matrix version of the 6-dimensional V sub S. Okay, again 4x4. Okay, and remember that we got V sub B and V sub S in square brackets, okay, from the following. So recall, right, V sub B was in fact T inverse T dot, okay, and V sub S was T dot T inverse. Okay, so if we want to go from V sub B to V sub S, then we can just write V sub S is, right, T inverse times V sub B times T, okay, or equivalently, V sub B is T times V sub S times T inverse, okay. Aha, so we're seeing this again, T times, okay, this something here. We saw this in the product of exponentials formula, right? T, T inverse, and sandwiched between them is this 4x4 matrix, okay, with a skew symmetric part and a 3 vector. 바뀌었나? Like this. Sorry, got this backwards. Okay, I think now's a good place to stop, so let's stop here.